Math 1314, Tyler Junior College, Section 3.1, Quadratic Functions. Graphs of quadratic functions in standard form. In the previous video, we introduced standard form, which is essentially a basic quadratic function that's been stretched and possibly reflected if the a is negative, and has been translated horizontally and vertically, and as a consequence is real easy to keep track of the vertex, because originally it was at the origin. If we move left or right followed by up or down, we can track the vertex. And the axis of symmetry is just x equals the x coordinate of the vertex. I didn't mention it before, well, I kind of did, but the whole opens up and opens down argument is still the same. If the leading coefficient is positive, the parabola opens up. If it's negative, the parabola opens down. So let's see if we can do the same thing for this function that we did for the previous one that was in general form. Suppose f of x equals 2 times the quantity x minus 1 squared minus 18. Does the parabola open up or down? Where is its vertex? Where is its axis of symmetry? Where are its x-intercepts, if it has any? Where is its y-intercept? And sketch the graph, including the symmetric image of the y-intercept. So almost the same discussion as before, just slightly different approach to locating some of these pieces of information. Let's start with the opens up or down. That's pretty easy. The 2 is positive, the parabola opens up. How about the vertex? Don't need a formula, you need to look and think. Starting with the -1. When you subtract a number from the x, what direction does that move the graph? You would think left, but it actually moves it to the right 1. And the minus 18 at the end does what you think, moves it down 18. Or you could just look at this and say, all right, vertex, take the opposite of the number I see -1, its opposite is 1, and take the number here that you see. Looks positive, it looks the same, that's the important part. -18, which is exactly where we would land if we started at the origin, went to the right 1 and down 18. Axis of symmetry, x equals the x coordinate of the vertex, so that's easy. Now for the x-intercepts, we're going to have to do a little bit of work. We're going to have to solve the function equal to 0. So let's go ahead and set it up. If you're so focused on always using the quadratic formula, you're going to take a lot longer to do this problem than you should. Excuse me. I drink water. But if you'll recall, in the videos about solving quadratic formulas, one of the approaches was specifically for when a quadratic equation had a single x term, and that was using square roots. Because there's only a single x term on the left, I can just systematically solve for this by getting rid of everything on the left side, starting with the 18. So if I add 18 to both sides, I get 2 times the quantity x minus 1 squared equals 18. Recall that the technique here is to first isolate the squared part. The squared part is this. So once we're done isolating that, we can hit it with the square root. Divide both sides by 2 to finish isolating the squared part. So we get x minus 1 squared equals 9. Now hit both sides with the square root. X minus 1 squared equals the square root of x minus 1 squared equals the square root of 9. The square root cancels the square. And don't forget that in this technique, now is the time to use a plus minus. The square root of 9 is 3, so we're at plus minus 3. Move the 1 to the other side to get x equals 1 plus or minus 3. This is 2 separate problems. X is equal to 1 plus 3, and x is equal to 1 minus 3. So our first x-intercept is at 4, and our second x-intercept is at -2. So we have 2 x-intercepts. One of them is at 4, 0. The other is at -2, 0. Same answers you would have gotten if you had FOILed the parentheses, distributed the two, combined the like terms, and then gotten out the quadratic formula, or tried to factor from that point forward. Now for the y-intercept. The y-intercept is always the value of the function when you substitute 0 into it. But be careful. As I mentioned a couple of videos ago, the y-intercept is not just automatically the constant at the end. In general form it is, because when you substitute the 0, every term vanishes except the last one. But in standard form, that's not the case. If I substitute 2 for the 0, it doesn't get multiplied by anything first. The first thing that happens to it is 1 gets subtracted from it, making it not a 0 anymore, which means I can't just assume things are going to vanish. But I can work this out. Negative 1 squared is 1. 2 times 1 is 2. And then 2 minus 18 is negative 16. So we get a pretty low x-intercept at 0, negative 16. But that's not a real surprise because the vertex was even lower than that. So to find the y-intercept, just put 0 in and work it out. Don't just automatically assume it's the number at the end, because it's not always. All right, we're ready to sketch this graph. Now before I draw an x and a y-axis, you should scan the points that you already know and sketch your axes accordingly. The x-coordinates that I know about are 1, 4, negative 2, and 0. So I need a little room to the left, a little more room to the right, but not too far in either direction. By contrast, my y-coordinates are all really big negative numbers, or 0, which means I need a lot of space below the x-axis and not much above. So I'm going to draw a really high x-axis up here, and I am going to take the time to mark off some spaces. And let's say, well, if I'm going to do that, I might as well draw straight lines. Imagine that, using a straight edge to draw a straight line segment. By the way, do you know the difference between a line and a line segment? It's geometric. A line segment has a beginning and an end. A line, in theory, goes forever. You can't draw a line. The best you can do is represent a line by putting arrows on it and saying, see, I can't draw it forever, but I can say that it goes forever. Anyway, enough of the geometry lesson. I need a lot of space going down this y-axis, so let's see. I think I'm going to put a mark every 2 inches and let each one of these represent the number 2. In other words, I'm scaling this on a scale of 2. So we'll say that this is negative 2. So negative 2, negative 4, negative 6. And for consistency, I'll use the same scale along the x-axis, but as we've already discussed, we don't need to go very far in either direction. The leftmost we need to look on the x-axis is at negative 2. The rightmost is at 4. Okay, so let's find everything. The vertex is at negative 1, comma negative 18. So just kind of seeing how far over I need to go. All right, so 2, 4, 6, 8, 10, 12, 14, 16, 18. Did I count that right? 2, 4, 6, 8, 10, 12, 14, 16, 18. I don't think I said 8. I don't think I said 10. I might have. You could rewind the video and see if I did. But the vertex seems to be down here. And knowing that this parabola opens up, I'm going to label it below the vertex so that my parabola doesn't run through my ordered pair. The x-intercepts are at 4, 0 and negative 2, 0. Oh, I didn't draw my axis of symmetry. Let me draw that. Goes right through x equals 1. Oh, wait a minute. This isn't x equals 1. I just botched this up. Yeah, I know I didn't say it. You may not have seen it, but I used this first mark as 1, but this first mark isn't 1. This first mark is 2. 1 is halfway in between. Fell victim to the oldest mistake in the book. Know your scale on your axis. That's about 1 inch over. Well, that makes sense because each mark was 2 inches. Where was 18? 2, 4, 6, 8, 10, 12, 14, 16, 18. 1 inch over. Right about there. Let me get the black marker out. Alright, this is a lot easier on graph paper where you don't have to mark everything up. It's already marked for you. Alright, so anyway, as I was saying, there's the vertex now properly plotted. The 2 x-intercepts are up there. My axis of symmetry goes straight through 1 both on the x-axis and through the vertex. So there's my axis of symmetry. The y-intercept is at 0, negative 16, which is right about here. So 0, negative 16. Now, where's its mirror image? Well, the y-intercept is one space to the left of the axis of symmetry, so its mirror image will be one space to the right. So it'll be at 2, negative 16. We're going to get kind of a skinny parabola, but that makes sense if you think about it. I think we have enough points. Not bad. Not bad at all. But why is this parabola so skinny? Oh, the 2 invoked a stretch of 2 in the vertical direction. So everything is twice as high as it would normally be. That's why it looks skinnier. So, sketching the graph of a parabola in standard form is just like sketching the graph of a parabola in general form. How you get the information is a little different though. The vertex is easier to get. Some people would argue that the intercepts are harder. I would argue that the x-intercept is easier because there's only one x, but the y-intercept requires a little bit more work because the 0 doesn't just go in and destroy everything it touches.